Yeah, good evening, everyone.
Good evening, ma'am.
Uh, the- Yeah, okay, so this is the open session for week two. Okay, let me share my screen, then we will start.
Ma'am, we are going to discuss the concept of week 2.
Yeah, we will discuss the concept of week two.
Thank you, ma'am.
Ma'am, some portion of the week one was remained to be taught by Prasan sir in the last turn.
Okay. Uh,
Multiple
what?
random variable that topic was remaining.
Okay, so see, I will teach week two. Okay, and the concept that will be used, I will teach that also. Okay.
Okay.
Yeah, so my screen is visible.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, so in week two, there are majorly two topics. So first one is independence of the random variable. Okay, in which we will study independence of two random variables and for multiple random variables. And the second major topic is function of random variables. Okay, so we will start with the first topic. Independence of two random variables. Okay, so let us suppose we have two random variables x and y. Okay, the range of x is tx and the range of y is ty. Okay, now x and y are independent if the joint PMF is equal to the product of their marginal PMF. Okay, and here it is true for all T1 belongs to Tx and T2 belongs to Ty. Okay, so if you need if you have to prove two random variables independent, then you have to check this condition. Okay, and what is this? This is the joint distribution of x and y, and this is the marginal distribution of x, and this is the marginal distribution of y. Okay, so you need to check whether their joint distribution is equal to the product of their is equal to the product of their marginal distribution
Marginal
or not.
distribution.
Okay, yeah,
Excuse me,
and
ma'am.
there are yes.
I'm like in the from the previous formula,
Hmm.
from where we get this joint PMF, fxy t1 t2 equals to in generally it is fx of t1 comma and t2 y equal to t2. Then we calculate accordingly. But here, like you have directly mentioned it.
See, I will tell you how this formula comes. Okay, see,
Okay, okay.
so there is a remark. Okay, so see, so generally you have studied like fxy t1 comma t2. It is equal to the fy given x equals to t1 t2. So this is the conditional distribution of y given x. Okay,
Yeah.
multiplied by the marginal distribution of x. Right. Okay, so this is the general case. Right.
Yes, ma'am.
Okay. And if x and y are independent, so what happens? If y given x equals to t1, so how we can write it? Like we can write it the unconditional distribution of y.
Yes, ma'am.
Got this? Since x and y are independent,
Okay,
so
fine.
that is why unconditional distribution becomes equal to the conditional distribution becomes equal to the unconditional distribution. Okay, so now you will put this value into this formula and you will get this, right?
Yeah, understood, ma'am.
Okay. Yeah, now we will understand by some examples. Okay, so let us take example. T1 and T2, which are the values of x and y. So let's suppose T1 takes values 0 and 1 and T2 takes values 0 and 1. Okay, and values given are 1 by 4, 1 by 4, 1 by 4, 1 by 4. These are the joint probabilities. Okay, now we have to check whether x and y are independent or not. Okay, so we will check by using that formula. Okay, so here what is the value of fxy at 0, 0?
1 by 4.
Yeah, it is 1 by 4. Okay, now we have to check the product of marginal distribution of x at point 0 into marginal distribution of y at point 0. What is this
Ma'am,
value?
it will be half into half equal to 1 by 4.
Yeah, half into half, which is equal to 1 by 4. Okay, so we can see that these two values are same here. Okay, and similarly, we can check for other cases also, like for fxy 0, 1, for f1, 0, for f1, 1 also, we can check all these conditions. Okay, now can you please tell me that whether the condition of independence will be satisfied or not?
No, ma'am, we need to check for all.
Yeah,
I
we
think
need to
it
check
will
for all.
satisfy for all.
Ma'am, it will
So
satisfy
it will satisfy. Okay, so everything
for all
is
the
okay.
possibilities.
So, okay, what you need to find here, you will need to find the marginal distribution. Okay, okay. So what it will be? It will be 1 by 2, 1 by 2, 1 by 2, and 1 by 2. Okay. So you know
Yes.
all the values. Okay, you can check about that. So here, for all the values of T1 and T2, this condition will be satisfied. So x and y will be independent here, right? Is it clear to you all or not?
Ma'am, can
Yes,
you
ma'am.
repeat the last step once again?
Okay. So see what we have to do. We need to check whether the joint distribution is equal to the product of the marginal distribution or not. Okay, and we have to check it for each case. Like what values x and y are taken, 0 and 1. Okay, so what will be the possible combinations of joint distribution for 0, 1, 1, 0, 1, 1, and 0, 0.
0,
Okay,
0.
so we have to check at these points the joint distribution of x and y is equal to the product of their marginal distribution or not. Okay. Uh, okay, let me take for another case also. So let us take for 1, 0. Okay. So what is the joint distribution in this case? Okay. So x1 is 1, which is this value, and x is 1 and y is 0. So this is the joint probability, right? 1 by 4. Okay. Now fx at point 1 into marginal of y at point 0. Okay. So what is this? So marginal of
Half into
x
half.
at point 1 is 1 by 2 and marginal of y at point 0 is 1 by 2, right? So 1 by 2 into 1 by 2 is equal to 1 by 4. Okay, similarly you can find for all of these cases, right? And you
Yes,
will
Yes,
see
ma'am.
that the condition is satisfied for all the cases. Okay, so we can see that x and y are independent here. Okay, now let us take another example. So now here the joint probability is 1 by 2, 1 by 4, 1 by 8, and 1 by 8. Okay. Now check for independence. Okay, so let us take for 0, 0. Okay. So first we will find the marginal. So what will be this value? Can anyone tell?
5 by 8.
5 by
Sorry.
Marginal of y at point 0.
Marginal y 0.0.
3 by 4.
Yeah, it will be 3 by 4. What we do, we add these two values and you will get the marginal of y at point 0. Okay. Similarly, for at point 1, you will add 1 by 8 plus 1
1
by
by
8.
4.
Okay.
1 by 4.
It will be 1 by 4. And marginal of x, similarly, you can find. So it will be 5 by 8.
And
And this will be 3 by 8. Okay.
Mm.
Now, what is the joint probability at point 0, 0?
1 by 2.
Yeah, 1 by 2. Now, what we have to find? We have to find fx, which means the marginal of x at point 0 into marginal of y at point 0. Okay, what is this value? It will be 3 by 4. Okay.
Into
Oh, sorry,
5 by 8.
fx, yeah, fx is 5 by 8. Okay. Let me write it clearly. So fx at point 0 is 5 by 8. And fy at point
Into
0
3
is 3
by
by
4.
4. Okay. Now it will be 15 divided
15
by
by
32.
32.
Okay. So here we can see that fx y at 0, 0 is not equal to fx at point 0 into fy at point 0, right?
Yes, ma'am.
So can we say that x and y are not independent?
Yes, ma'am. It is not independent.
Okay. So one point which is to be remembered here. So suppose if we have, if you have to prove that two random variables are independent of each other, okay, then this condition, then this condition should be true for all the cases. Okay, so
Can
I
you
have written
see if it
this
is
line.
different for one is not matching, then all of them is right?
Yeah. So yeah, this thing I'm telling you that if you have to prove two random variables are independent, then this condition should be true for all the cases. Okay, and if the condition is not satisfied even for one case, okay, which is the case here, as the joint distribution is not at 0, 0 is not satisfied this condition. So we can say that x and y will not be independent. So if for one situation only the condition is not satisfied, okay, then we don't need to check for others, right? The
And
variable will
if
be dependent.
and if it is dependent, then we have to check for rest of all the conditions.
So
Or
suppose if
just
see,
in the previous case, we have proved
in
for only
previous
for
case,
one.
no, see, we checked for each case. I did not write for all the cases, but we need to check for all the cases. Okay.
Okay.
You can see by the table only that the product of the marginal will be equal to the product of joint. Sorry, will be equal to the joint probability, right?
Yes.
So that's why I have not written for all the values. Okay. But you need to check for each cases.
So
For each
if
case, okay?
if it is independent, then we have to check for all the cases. If it is not dependent, and if
No.
only one case is proved,
see, you will check first. Okay, you will check the condition, and then you can conclude that whether the variables are independent or not. Okay.
Yes.
So suppose you are checking for this case, the condition is satisfied. Okay, then you will check for another case. Okay, condition is again satisfied. Okay, then you check for this case, condition is satisfied. For this case, okay. So here the condition is satisfied for all the values of x and y. Okay, then you can say that x and y are independent. Okay. Now in the next question, you check for only for this case, okay, and the
case.
condition is not satisfied.
Not satisfied.
Then
The
you don't
condition
need to check.
fails.
Yeah.
The condition fails, so you don't need to check for other cases.
Other cases.
Okay.
Yes. Okay.
So if only for one case the condition is not satisfied, you can say that variables are not independent.
X
Okay.
and Y are dependent.
Yeah, X and Y are dependent. Okay.
And we do not need to check for any other
For,
cases.
yeah. Yeah. But suppose it gets satisfied, then you will check for another case. Okay.
Yes, then we should proceed further.
Yeah.
Ma'am, your voice has a bit of disturbance. Can you check if it's positioned correctly, the microphone?
No, the voice is fine.
I think it, I mean, it is fine. I can understand what she says, but I think it can be better. Ma'am, is your microphone positioned correctly?
Yeah, it's fine from my side, I think. Anyone
Okay.
else also feeling the disturbance?
No, ma'am, it is okay, no problem as of now.
Okay.
At least I don't see a problem.
Okay.
Ma'am, it would
so
be
the-
better if your voice is a little bit louder.
Okay.
Otherwise, it is fine.
Okay, see, our next topic is the independence. This. Yeah, so now we will study about the independence of multiple random variables. My voice is fine now.
Yes, ma'am.
Okay. So suppose we have n random variables, x1, x2, x3, and up to xn. Okay. And the range of xi belongs to txi. Okay. So this is the range of xi. Okay. Now we can say that x1, x2, up to xn are independent if the joint density, the joint probability mass function.
But
Yeah, sorry, it is for discrete. In week 2, we are studying for discrete case only. Okay. So f x1, x2 up to f xn, t1, comma t2 up to tn. So it is the joint probability mass function of x1, x2 up to xn. Okay. So it should be equal to the product of marginal distribution of
marginal
x1, x2 up
distribution.
to xn. Okay. And this is also for all ti belongs to txi. Okay. Right?
Yes, ma'am.
Yeah, sure. Okay, now the next thing is, okay, so if you're given more than 2 random variables, then also you have to check whether their joint probability mass function is equal to the product of their marginal or not. Okay, same thing you have to follow for multiple random variables also. Okay, now the next thing is independent and identically distributed random variables. Okay, and in short, we write it as IID random variables. Okay. So if random variables x1, x2 up to xn are IID, then there are two conditions which they should follow. So first is all the xi's are independent. Okay. And the next condition is the marginal PMF of each xi are, or we can write it, marginal PMF fxi are identical. Okay. So what does it mean? So suppose you are given n random variables, then each random variable should be independent of each other, and their distribution, whatever they are following, it should be same for all. Okay. So suppose x1 is following binomial distribution with parameter say 5 comma 1 by 2. Okay. Then x2 should also follow the binomial distribution with the same parameter 5 comma 1 by 2. Right. Suppose if x3 is following binomial 4 comma 1 by 3, then can we say that all these three are following the same distribution?
No,
Or is
ma'am.
it different?
It
No,
is,
right?
it is different.
Yeah. So yeah, it is different. Okay. So if two distribution are following, say, suppose they are following binomial distribution, so we need to check for their parameters also. Okay. It's not like if they are following binomial, then they are same, then they are identical. Okay. We cannot say only in that on that basis. Okay. Their parameters should also be same. Yes.
Ma'am, is there any way that if suppose I have got a data set and I am checking whether it is IID property, I am checking and I found that do the variables are following binomial distribution, but I came across something like this of x2 and x3. So is it some statistical method so that I can convert x3 into x2 similar to x2 distribution, so that
No,
I can
if they
proceed?
both are following different distribution, then you don't need to
They are
convert it.
following binomial only, but the parameters are not same.
No, then they cannot be identical in that case.
Yeah, so to make them identical, is there any method, statistical method, or we have to go for another method to solve such kind of problem?
Yeah, we can use another methods.
Okay.
We don't need to
So there
convert
is no
them into the same.
method to convert it to make it IID.
I think so.
Okay.
You don't need to deliberately make into the IID random variables. Okay, if it is given, then you will solve the questions accordingly. Okay, it's not like you always have to make the random variables IID. Okay, you don't need to convert them into the same distribution. Okay, so now let us take an example of it. So suppose I am tossing a coin 4 times.
And these are two conditions for IID.
Yeah.
Xi's are independent and marginal PMF Xi's are identical, right?
Yes.
Okay.
Okay. So suppose we have a fair coin and we are tossing it 4 times. Okay. And suppose we are having 4 random variables, x1, x2, x3, and x4. Okay. And suppose here xi is representing, it takes value of 1 if head occurs, if head appears at ith toss. Okay. And it takes value 0 if tail occurs at ith toss. Okay. So here each x1, x2, x3, and x4 taking the same value 1 and 0. Okay. On the basis of this condition, if head appears, then it takes value 1. And if tail appears, then it takes value 0. Okay. And it is same for all the random variables, right? And they are independent also. You know, the different tosses of coins are independent of each other, right?
Yes.
Yes, ma'am.
Okay.
Ma'am, I have a doubt.
Yeah.
So if it is like x1 is in the range 1 to 6 and uniformly distributed, and x2 is in the range of 1 to 5, so are they identical or not?
Yeah, so you are saying that x1 is following uniform distribution. So
Over 1.
okay, so yeah, suppose x1 is a variable which is following uniform distribution and taking value 1 2, suppose only 1 2. Okay,
Hmm.
and x2 is a variable which is also following the uniform distribution but taking the value 3 and 4.
Yes,
Okay,
yes. Okay.
so this is different.
Okay. And
Okay, so this
if,
is
yeah, yes.
the parameters should also be same. Okay,
Okay, if the parameters are same somehow, and but somehow they have different probabilities, then
sorry, what?
if the parameters are same but the probabilities of different in PMF
No, if
of these two.
parameter, so see, probability can be same for 2 cases or for 3 cases, but it will not be same for all the cases, right? For all the points, the probability will not be same because the parameters are different,
Hmm.
right? Then they are not identical. Okay.
Okay.
Ma'am, would you please scroll up?
Excuse me, ma'am. Ma'am, like
Yes.
what this example you have taken just now,
Hmm.
all the individual random variables x1, x2, x3, x4 have the same uniformity inside the if you take any type of binomial distribution also, because so this type of
See,
like yeah.
okay, I am repeating my question again, then you can ask. Okay, so what we are doing here, we have one coin, okay, and we are tossing it 4 times. Okay, and now I am taking 4 different random variables, x1, x2, x3, and x4. Okay, and what is xi? Xi means I is going from 1, 2, 3, and 4. Okay, I is 1, 2, 3, 4. Okay, so xi is taking value 1 if head appears, and it taking value 0 if tail appears. Hello.
Yes, ma'am. Yes, ma'am. Understood.
Okay, so xi is only for the first child. Okay, so xi, or I am writing is xn for this case. So it will follow Bernoulli distribution with 1/2 as the probability
Yes,
of
ma'am.
success. Okay, because we are taking a fair coin, so the probability of success will be 1/2. Okay, and x1 is for only the first toss. Okay, so it is just a Bernoulli trial, right? So here each x1, x2, and x3, x4 are the Bernoulli with parameter 1/2. Okay, so all the xi's are following the same distribution. Okay, with same parameter value. Also, they are independent of each other. Different tosses of a coin will be different. Will be independent from each other, right?
Yes, ma'am.
Okay, so
Ma'am,
both the conditions are getting satisfied.
yeah, ma'am, can you show one example which is not in IID distribution? Like,
Yeah, you can take any like
Time
x1 is
series, time
following
series, time
symmetric
series data.
distribution. Okay, with some parameter like 1/2, and x2 is following like binomial distribution. Okay.
I'm like real life example type, ma'am. I'm just a little bit confused here. That's why, because generally we encounter only the same distribution in general. Like,
Okay. So see,
Would that unfair coin would help here, because unfair coin will not have the
okay, yeah.
right.
And any of the time series data do not follow IID criteria because they are dependent on each other.
I think bias coin will help. Time series, I'm not.
Yeah. See,
Ma'am, I
They are
also have.
autocorrelated. For that reason, they are not
okay, suppose
independent.
I think bias coin is not example of this because let's say probabilities are 0.4 and 0.6, but that is fixed, no?
uh, okay, suppose x1 is a random variable which I took in this example. Okay, it is following Bernoulli 1 by 2, and you are taking another random variable, suppose x2, and it is giving you the number of customers coming from 1 to 2 p.m. Okay, so these are two different things. Random variables are following two different distributions. Okay.
Okay.
I'm a bit confused for x2 in your example. It should be 1 if head appears on the second toss. So shouldn't it be like head tails? No, wait.
See,
It should not follow Bernoulli. It should rather follow binomial.
no. See,
For
what
x,
I am taking, it's not the number of head appears. Okay.
oh,
I'm
okay.
not taking, okay, it's not number of head appears. It's
I-
just like if head appears, then we will denote it by 1, and if tail appears, then it will take
Okay.
value 0, right?
Okay.
It's
Yeah.
simple. Okay, it's just a Bernoulli trial. I'm not taking a binomial distribution. Okay.
Okay.
Okay, clear?
Yes, ma'am. Yeah.
Okay, fine. Okay, now the next topic is
Hello, ma'am.
yes.
Is this example of IID?
Well, this example or this one?
Yeah, ma'am. First one.
First one, yeah. First one is the example of IID.
Okay.
Okay, yeah. I have to write it here that x1, x2, x3, and x4 follows IID Bernoulli 1 by 2. Okay. You need to check two conditions, whether the random variables are independent or not, and they are following the same distribution with same parameter value or not. Okay.
Yes, ma'am.
Okay. Yeah.
One
the next,
question.
yes.
Yeah, see the first if it is IID thing, we need to find the comparison of x1, x2, x1, x3, x1, x4. That's why you have to check our independency.
Sorry, what?
The independent among x1, x2, x3, x4, right? So we need to compare all of them together, is it? x1, x2, x3. I mean, each one we have to compare pairwise, or how is it the independent part?
Yeah, independently you will check whether x1 is independent of x2, then x1 is independent of x3.
x1, x4, then x2, x3,
Okay.
then x4.
Ma'am, this was in one video that if if we take all of the random variables together and that
See for
is dependent.
see if this condition is satisfied, okay, then all the set becomes independent for multiple random variable case. Okay.
Right.
Okay, so if this condition is satisfied, then you can see that x1, x2 jointly will also be independent, and x1, x2, x3 will also be independent. Okay, you can take any set and it will be independent. Okay.
True. Okay.
Okay. Yeah. So the next is memberless property of geometric distribution. Okay. So let x follows geometric distribution with parameter p. Okay. Now what will be the PMF? Can anyone tell? What is the PMF of geometric distribution?
1 minus 8 whole raised to k.
Okay, I am taking the value x. So tell me according to x.
X minus 1.
Yeah, x minus 1 into p. Right? Okay. And the value of that x will be taken will be 1 to up to infinity. Right?
Yes.
So here in the memberless property, we will see two things. First is that the probability that x is greater than n. Okay. We will find this, and next we will find x is greater than m plus n. Okay. Given that x is greater than m. Okay. So now the first is probability x is greater than n. So how we can write? That's summation probability x is equal to x, and x will start from n plus 1, right? Since n is greater than n, right or not?
Yeah.
Okay, and it will go up to infinity, right?
Yes.
Okay, so we can write it as n plus 1 to infinity, and the distribution is 1 minus p to the power x minus 1 into p. Okay, now we will open the summation. So we can take p as common. So it will be 1 minus p to the power n plus 1 minus p to the power n plus 1, and so on, right? So in the next step, we can take 1 minus p to the power n common. So it will be 1 plus 1 minus p plus 1 minus p square, and so on, right? Now, what will be the summation of this series? Anyone know?
It's geometric.
Ma'am, geometric
Yeah.
progression.
It is a geometric progression. Okay, so it will be 1 divided by 1 minus p. So is it clear to you all or not?
Yes, ma'am.
Ma'am, can you
Yes, ma'am.
explain one more time?
Okay.
Yes, ma'am.
Okay. So suppose we are given a series 1 plus r square plus r cube plus and so on up to infinite terms it goes. Okay. So it is an infinite geometric progression, and the sum is equal to the a upon 1 minus r. Okay. And what is a here? A is the first term of the series.
Yes, ma'am.
Okay. And r is the common ratio. Okay.
Common difference. Yes, ma'am.
It's not common difference here. It's common
Ma'am,
ratio. Okay.
AP, ma'am, AP में common difference.
हाँ AP में common difference होता है. Okay. So a is 1 here and r is 1 minus p. Okay. Okay. So what it will be? P 1 minus p to the power n upon 1. So it will be p again. Okay. So probability that x is greater than n, it will be equal to 1 minus p to the power n, right?
Yes, ma'am.
Okay. Now we will calculate the next part. The next is probability that x is greater than m plus n. Okay. Given that x is greater than m. Okay. So tell me how I can write it. So it is the conditional probability.
Yes, ma'am.
Yeah.
Okay. So how I can open it?
Intersection.
Yeah. So x greater than m plus n. Intersection x is greater than m divided by
P of x greater than n.
X greater than m.
Yeah. Okay. So can I write it like probability of x is greater than m plus n only?
Yes.
Yes, ma'am.
Yes.
That is the common region.
Okay. So it is the common reason. So we can write it like this. Okay. And we have already calculated this part. Okay. So how we can write it? It will be 1 minus p to the power m plus n, right? By using this formula.
Yes, ma'am.
Okay. So it will be m plus n
Divide by 1 minus p to the power m.
Okay. So this step is clear to everyone or not?
Yes, ma'am. It's clear.
Okay. So it will be
Don't mind, can you repeat it once again? Only this second.
this probability, this intersection part.
Yes.
Okay. So see.
The intersection, yeah, we need to do the intersection of those two. That's a normal, this one, right? When we do a conditional, this one, then how are we reducing to greater than? I mean, like in the second arrow that we are reducing to only writing second one, right?
So you are asking how I write this thing or
Correct.
something else.
Either,
Yeah, okay.
excluding
So
this one, yes.
yeah, okay. So see, suppose this is our line, okay. This is our value m, and this is m plus n.
Right.
Now I am taking m is 2 and m plus n as 2 plus 1, which is equal to 3. Okay.
Right.
So what it is saying that x is greater than m plus n, intersection x is greater than m. Okay.
Right.
So greater than this, which means this part, and greater than this, which means this part. Okay. And intersection. So what is the intersection? Intersection will be
m plus n, 3.
Right.
This part, right?
Correct.
Okay. So in this way, I have written this. Okay.
Okay. Okay. Sure.
Okay. So it will be 1 minus t to the power n. Okay. Now what
Yes,
can I
ma'am.
write it? Probability x is greater than m plus n. Given that x is greater than m, so can I write it? It is 1 minus p to the power n. Okay. So can I write it? Probability x is greater than n.
Yes, ma'am.
Okay. Now can you conclude or interpret what this statement is telling you?
Like it is something like this, that if we have tried this M trials and we didn't get any success, so we can like remove them from our observation, and then whatever the next number we try, we can take the geometric distribution only for that.
Okay, so let me explain. So what is it? Suppose okay, suppose you are calling a person, or okay, let us take simple example of tossing a coin only. Okay, you are tossing a coin. Okay, and what is your success? Your success is if head appears, then it is your success. Okay, so it is saying, suppose that for you have tossed the coin 3 times. Okay, and you have not got a head. Okay, and what x represents in the geometric distribution? Hello.
Number of attempts.
Yeah, number of trials to get first success. Okay, so until the 3 tosses, you have not got the first. You have not got the head. Okay, and now you are saying the probability that you will not get the head for the next 4 tosses also. Okay, which means 4 plus 3. Okay, so this probability will be equal to probability that x is greater than 4, right? Like if
Yeah.
you're starting again and you're saying that what is the probability that we will not get head in the next 4 tosses. So these probability are same. Okay.
Is it?
Ma'am, tell me again.
Okay. So see what I'm saying. Suppose you are taking a experiment. You are tossing coins, and what is the probability? What is the success here? If head appears, then you are considering it as success. Okay. You have tossed the coin for 3 times, and you have not got the success, which means head did not appear in the first 3 tosses, right? So x is greater than 3. Okay. Now you are saying that what is the probability that we will not get head, or we will not be getting the success for the next 4 trial also. So next 4, which means total 8. Sorry, total 7.
Yes, ma'am.
Right. So total it is 7, or we can say for the next 4 tosses. So it is similar to like you are starting your experiment again. Okay, you have not tossed the coin, assume. Okay, and now you are saying that you will not get the head for the 4 trials.
Okay.
Okay, so it is same as that. Is it clear to everyone?
Yes, ma'am.
Yeah, it's clear. Maybe one question, madam. If
Yeah.
anything goes above 7, I mean, above that number itself, you will never get, is what it meaning it. See, because we are talking about next set. See, we got 3 times, we didn't get any head. So above 3, if you repeat once again another set 3 or 4, we will not get it. So if you repeat once again, let us say third time also, we will not get it. So that means that greater than is always true up to infinity, right? Am I clear on the question? Because the first, because greater
sorry, I
than,
did not.
sorry, shall I repeat?
Yeah, you should repeat.
Yeah. See, in the case of coin example, we attempted 3 times. We did not get the head. That is known. Now we are saying no, greater than 7, we are saying, right? 4 plus 3, whatever, right?
Yeah.
Which is equivalent to the initial try what we try now, that 3 times we didn't get it. So that we the equal to, that's what we are anticipating, correct? What I mean, next set also you will not get it head. That's what it means, right? If you
you are calculating this probability.
Correct.
So it is like you are restarting your experiment.
Correct.
Okay, and initially you are saying that the probability that you will not get success for the 4 trials.
Correct, right? So
okay,
if we repeat this repeatedly for n number of times up to infinity, we never get that's what it means indirectly. I mean, it'll be the same thing, right? We will not get a head at all in the current example if you repeat it indefinitely, because it's greater than m. We are saying.
See what does it mean that? How should I explain you? It is just saying that this probability is same to this thing. Okay.
Okay.
Okay, it's not like.
Is it not for the entire range? What is going to take?
Yeah, it is possible for entire range. Like suppose you are saying that you have tossed for 10 times, and for the next times, for the next 15 trials, you are saying. So total it would be 25. So it is greater. It is equal to that probability that x is greater than 15. Okay. So what does it mean? What this formula tells us about that this probability is not dependent on the previous trials. Like you are okay. So you have done 10 trials. Okay. You have this is the case that you have already done 10 trials. Okay. And you are talking about the next 15 trials.
Correct.
Okay. And in this case, what does it mean? That you have not done any tosses. Okay. And you are starting your experiment and you are saying that you will not get head for the 15 tosses. So this probability is same as this probability.
Okay. Okay.
Okay.
Sure.
Yeah, this is the thing. Okay.
Sure.
Ma'am, the first 10 trials are immaterial. We will have to consider only the next 15. Is it the way we are thinking?
Yeah, it does not depend on the last 10 trials. This probability does not depend on the last 10 trials, that in the next 15 trials you will be getting the success or not.
Last 10 trials means starting from 1, right? 1 to 10 we are not considering. And
okay, so it is just like you are restarting your experiment and saying that in the next 15 trials you will not be getting success. Okay, no matter how many times you have tossed your coin and you have not got success. Okay, let me take another example.
Suppose number line is of 20.
Okay, let me take another example. Okay.
No, I'm just trying to explain what I understood. Suppose there are 25 points on the number line. We are skipping. We are like for
like it is
10.
1, 2, 3, 4, and 5 up to 10. Suppose
to 10 we are not bothered.
Okay, and next 15 it goes up to 25. Okay.
Okay.
So probability that x is greater than 15. So suppose 15 is this side. So this probability is equal to x is greater than 25. This. Given that this probability. Okay. Actually, it's not possible to show it on the number line. It will be the wrong representation in this case. Okay. Okay, let me take another example.
Yeah.
Suppose you are should I explain next or not?
Take another
okay,
example.
Suppose you are calling one person. Okay. And what is the success? If the person receives the call, you are considering it as success. Okay, and if he doesn't pick up your call, it is failure. Okay, so you have called the person 4 times, suppose. Okay, and he didn't receive the call. Okay, so what is x? X is greater than 4. Okay, we are writing that x is greater than 4, right? You have called the person 4 times and he didn't receive the call. Now you are saying that for the next 5 calls also, the person will not receive the call. Okay, right? So what it equal to? It will be equal to, suppose, okay, this is some, this you can assume one scenario. Okay,
X is greater than 5.
okay, and okay, so what x is greater than 5 tells you that, suppose the next scenario, in the starting you are saying that you will call the person 5 times and he will not receive the call. Take it as 2 different scenarios. Okay, here what we are saying that you have called the person 4 times and you are talking about the next 5. Okay, so this is same as that in the starting you are saying that for the 5 calls the person will not be receiving the call. Okay,
Sure, madam. I think, sorry, I'm okay. If need, we can take it in the next session or something. My question was,
okay,
because we are saying greater than 5, greater than x, greater than, it can go to any number up to the infinity, whatever.
yeah,
So
yes.
will it be equal to the one what we had, the right side one is what the question I had. If you want, you can discuss in the next session. Please proceed, yeah, with the other topic.
Okay, okay. See, it is the conditional probability. Okay,
Right.
and this is the unconditional. Okay,
Hmm.
if you calculate it different, then it may be different. Like
Okay.
if you're taking the unconditional distribution for both the cases, but at one side it is a conditional distribution, and at another side it is unconditional distribution. Okay,
Okay.
so keep this thing in mind. Okay, yeah, the next thing we will study is the function of random variables. Okay, okay, so we will understand it by some examples. So suppose the first example is x comma y follows uniform. Okay, and we are taking a function of x and y, which is x plus y. Okay, so here z is the function of a random variable x and y. Okay, so what values that x and y together can take? So whether it will be 0 or 1, it can be 0 or 0. Okay, let's write 0 first and then. Okay. So it can be 0, 0, 0, 1, 1, 0, and 1, 1, right?
Yeah.
Okay. And what is the probability? What will be the probability? It will be 1 by 4 only, because it is the uniform distribution. Okay. Now, how we will find the value of z? Z is equal to x plus y. Okay. So we need to sum over the values of x and y. So x. So here 0 plus 0, it will be 0. Here 0 plus 1 will be 1. Okay. Now 1 plus 0, it will be 1, and 1 plus 1, it will be 2. Right? Okay. So what will be the range of x? What values the z is taking?
0, 1, 2.
So 0, 1, and 2. Okay. And what will be the probability that z is taking 0?
1 by 4.
1 by 4.
Okay. 1 by 4. And for 1?
1 by 2.
1 by
And a half.
Yeah, 2 by 4. Or yeah. And for 2, it will be 1 by 4 again.
1 by
4.
4.
Right?
Yes,
So
ma'am.
in this way, we find the function of a random variable. Okay. So first, the basic thing is to find the values that z will be taking. Okay. And then we find the probability of for different values that z is taking. Okay.
Okay.
Okay. Now the next example.
Excuse me, ma'am. Ma'am, like how
Yes.
you have decided the probability for 0, 1, and 2? I'm just trying
Yeah.
to.
See. So there are total 4 cases, right?
Yeah. Yes, ma'am.
Okay. And out of the 4 cases, 0 is occurring for one time only.
Okay,
Okay.
ma'am, fine.
So
Yeah.
it will be 1 by 4. Okay. For this also, it is 1 by 4 if you count it separately. Okay.
Yeah, yeah.
So 1 is also 1 by 4 and 2 is also 1 by 4. Okay. But this is same. Okay. So we will be
Okay, you're
considering it
taking
2 by 4. Okay.
Okay.
So 1 is occurring total 2 times out of the 4 times. Okay. So
Okay,
it will
ma'am.
be 2 by 4. Okay. Now
Okay.
let us take another example.
So if it is given as x plus y directly, we can add the value sum of those x and y, is it? The random variables.
Yeah, the function, as the function is given to you here, the z is equal to x plus y. So
Okay.
we will be taking x plus y. If it is given x into y, then we will be taking the value 0 into 0 and 0 into 1. It's like that. Okay. So the function will be given to you in the question, and accordingly you have to solve. Okay.
Okay.
So the next question is that x is following
Ma'am,
the
how
uniform.
this function is different from joint PMF function?
See, joint is mean that x and y are occurring together, but here what is z? Z is the sum of x plus y. Okay.
Okay, ma'am.
Okay, let me, I will show you some examples, then you will understand. Okay. The next is x is following uniform. The range is -5, -4, up to 4 and 5. Okay. And the function is defined as that it will be taking value x if x is greater than 0. Okay. And it will be taking value 0 if x is less than or equal to 0. Okay. Okay, so I am considering the fx is equal to y. Okay, just the notation. So the values that x is taking is -4, sorry, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Right? And since it is a uniform distribution,
Probability
okay,
is
so
what?
it is, okay, so it will be 1 by 11. Okay, 1 by 11. For each case, it will be 1 by 11 only. Right? Okay. Now, what is the function fx, which is the function of x, or I am considering it as y. So what it is saying that if x is greater than 0, then it will take value x. Okay. So x is greater than 0 means it will start from 1. Okay. So 1 is greater than 0, then what the value it will take? It is similar to x. Okay. So for 1, the value of fx will be 1. Right? And for 2, it will be 2. For 3, it will be 3. And similar for 4 and 5. Is it clear?
Yes.
Okay. And for x is less than or equal to 0, it is 0. Okay. So x is less than equal to 0 means from -5, -4, -3, -2, -1, and 0. It is 0. Right? Now,
Yes.
what values the y is taking or fx is taking?
0 to 5.
Okay, so y belongs in the set 0, 1, 2, 3, 4, and 5, right? Okay, and now what will be the probability for each value? For 0,
6
for
by 11.
yeah, for 0 it will be 6 by 11. Okay, and for 1,
1 by 11.
1
For
by 11.
rest, it
Yeah,
will be 1 by
One by
11.
yeah. For rest, it will be 1 by 11. Okay,
1 by 11.
okay, yeah. And you can also check whether the fx is also a random variable or not. Okay, so you can check that whether all these probabilities are greater than equal to 0 or not. Okay, there are two conditions for checking whether all the
Yes, ma'am.
probabilities are greater than equal to
Summation
0,
should be
and there's
1.
1, right? So this is satisfied. If you
Yes,
take
ma'am.
sum over all these probabilities, it will be equal to 1 only, right?
This is for
In the
validity.
previous question also you can check it. Okay, it will be equal to 1.
Won't it always be equal to 1, the summation, and won't it always be a random variable?
See, the function of random variable is also a random variable.
Right, okay.
Okay, and if it is a random variable, okay, so its PMF would follow the properties of the PMF,
Yeah.
right? Yeah, so it is also a PMF, right? So these are the different values that Y is taking, and these are the probabilities. So if you make a table, it will be the probability mass function, right? Okay.
Maybe one question, can you scroll up? Actually, it's where it's given as y, y is fx or something, or we are.
Yeah, Y is fx. You can write fx also. I just wrote it for the notation.
Okay, sure.
Later, if it zoom in, I take the screenshot.
Okay. It is just a notation. Okay, that's why I've just written one. Okay, this part. Done?
Yeah, yes, ma'am. Answer, ma'am. Yeah, okay, ma'am. Thank you, ma'am.
Okay. Okay, now let us take another example. So suppose you are throwing a die 2 times. Okay. A die thrown twice. Right? So x1 is the number at first roll. Okay. And x2 is the number at second roll. Okay, you are rolling or throwing a die for 2 times. So x1 is number at the first roll and x2 for second roll. Okay, now you are taking a function of x1 and x2, which is x1 plus x2. Okay, so what does it mean? That the sum of the numbers. Okay, so now tell me what values z can take.
2 to 12.
Yeah, it will be 2 to 12. And what will be the probabilities of taking these different values? See. So see, you are rolling a die 2 times, so there will be total 36 possible outcomes, right?
1 by 36 each.
No.
No, not 1 by 36. Okay, see, total 36 outcomes will be there, and okay, and what will be the outcomes for which z is equal to 2, which means that x1 plus x2 should be equal to 2. So how is it possible? Only one case. If at both the die one appears. Okay.
Ma'am, it can also interchange, right? We can also get 1 on the wait. Can we exchange the position?
It is the same, no?
See.
Right. There's only one way.
Yes,
Sorry.
yes, ma'am.
If you make the set 1, 1, 2 up to 1, 6, and okay, similar, there will be total 36, and 1, 1 is okay. So this is one event out of the 36. Okay. So probability of occurring 2, which means z taking value 2, it will be 1 by 36, right?
For 3,
Similarly,
it will be
for
2 by 36.
Yeah. Okay. So x1 plus x2 is equal to 3. So how is it possible? 1, 2 and 2, 1,
1, 2
right?
and 2, 1.
Okay. Only these two possibilities are there. So
Yes,
for
ma'am.
3, it will be 2 by 36.
Ah.
Similarly for 4. So if
For
x1
4, it
plus
will be 3 by
x2,
36.
yeah, so it will be 1, 3.
Up to 6, it
3,
will
1 and 2, 2.
increase, and from 7,
Okay.
it will decrease.
So it will be 3 by 36. Similarly, you can find
Then for 5,
for
it
the
will be
rest
4
of the
by
values.
36.
Yeah, you can find and write. Okay, I'm not writing for all the values.
Yes, ma'am. We can
Okay.
compute that.
So you can compute that. So yeah. So in this way, we find the function of random variable, their range, and the probabilities. Okay. Similarly, for 12, it will be 1 by 36, right? Okay.
Yes, ma'am.
Okay. Now the next thing is sum of two random variable. Taking integer values. Okay. So suppose we are taking two random variables x and y. Okay. And z again is x plus y. Okay. Now we are finding that probability that z is equal to small z. Okay. So how, can you please mute yourself? Okay. So how we can write? Z is a x plus y and it is equal to, yeah.
Excuse me, ma'am. Ma'am, what is this z is equals to?
Sorry.
Z is equals to what it
X
is?
plus y.
No, ma'am, probability p then bracket.
Oh yeah, this thing. Okay.
Please.
Yeah. So this C. So this is the probability that z is taking value small z. Okay. You can take any other variable also, but I am taking as small z, or you can write it like this also. Okay.
Yes, ma'am.
Okay. So generally, what we do, this capital alphabet are used to represent the random variables, and the small alphabets are used to represent the values that random variable takes, right? Generally, it is the, okay. So that's why I have written like this. Okay.
So small z will be z1 is equal to x1 plus y1, z2 is equal to x2 plus y2 in this way.
Sorry.
So small z is representing if we considering this equation z is equal to x plus y. So small
yes.
z will be z1 is equal to x1 plus y1, z2 is equal to x2 plus y2. In this way, we will
Yeah. So
calculate.
what? Yeah. So it is representing the value that z will be taking. See, in the previous example,
Yes.
the value of small z was 2, 3, 4, and 12. Okay.
Yes, ma'am. Got it. Got it.
That we got from x1 plus x2. Okay. So
Yes,
it is
yes.
that only. Okay. So how we can write it? So probability is that x plus y is equal to small z, right? I have just put the value of z here. Okay.
Yes, ma'am.
Okay. How you can find it? We can write it like probability that x is equal to small x and y is equal to small z minus x over the range of x. Okay. Or I'm just, for simplification, I'm just writing it. Okay. So how I have written it, do you understand?
I think y is nothing but is y1, right? Is something what it takes is something like x equal to x1, y equal to y1. Y1 is because z is the addition of x plus y. We are trying to subtract that way.
See, it is capital X and it is small x. So what does it mean? That capital X, random variable capital X, is taking the value small x. Okay.
Correct.
Okay. And since here it is written, it is given you that x plus y is equal to z, then suppose the capital X is taking the value small x, then what will be the value of y? The value of y will be z minus x only.
True.
Right?
Yeah.
Okay. So what you are taking the sum over the joint density. Not joint density, sorry, joint distribution. Okay.
If you don't mind.
Okay.
See, in the y can be written as a small y only, right? See, x plus y in the previous line, basically second blue line, x plus y is nothing but a each one, x1 value, y is.
So you are saying that I should write this x as a small x.
No, not
or
that.
x1.
No. The second right side one, z minus x, is nothing but a y1 value, right?
Sir, there is only one summation symbol, and we are summing over x, not over y, and we want both to change.
See what I have written. Firstly, I have written that probability that z is taking value z, small z.
Correct.
Okay, you can take as k or something else also.
Right.
But this is the standard way of writing, so I have taken this.
Fine.
I told, okay. Yeah. Now what I have what I do is I just put the value of z, okay, which is x plus y, in the place of z.
Correct. That right? Is small y, correct?
No, it's capital Y only.
Okay, sure.
Okay, yeah, it's capital Y only, not small y.
Sure.
Okay, yeah. Okay, so then I have written it like this.
Right.
Do you remember how we find if we are given fx comma y and you have to find the marginal distribution of x? Okay, then how do you find it? We take the sum over the joint density.
Correct.
Sorry, not joint density. I am joint distribution.
Right.
Okay. Okay. So over the range of x, I have written.
Correct. Okay.
So now, how we can write it like? We can write it as x. So this is nothing but the fxy, and the value of x is small x here, and the y is taking value z minus x here. These are same. Okay. Right.
Sure.
Okay. Similarly, you can write for y also. So probability z is equal to small z. You can write similarly that y is taking value is small y and x is taking value z minus y, right? Is it fine or not? Okay.
We are simply substituting x is equal to the value after calculating what's the expression is z is equal to x plus y. So yeah, x is equal to z minus y, and if we are taking y x, then it will be.
So what it gives you that suppose x is given 0, 1, and 2, and y is given as 0, 1, and 2. And x plus y is given to you as 4. Include 3 also. Okay, so if x is 0, okay, no, x will not be 0. If x is supposed 2, okay, then what y will be? Y will be 4 minus 2, right? Right or not? Okay.
Yes.
Or if x is taking value 3, then y will be 4 minus 1. Sorry, 4 minus 3. Okay. In this way, the formula is formed, right?
Can you explain the numbers what you have displayed once again? Sorry.
So it is just a random example. Okay.
Sure.
So like, okay, so I have written like x is taking 0, 1, 2, 3, and y is taking 0, 1, 2, 3. Same. Okay. And x plus y is equal to 4. Okay. So now I am saying that x is taking value 0. Okay. Then y, how can you find y? Y will be 4 minus 2. Okay. And suppose you are taking x as 3. Okay. Then how you can find y? Y will be 4 minus 3. Okay. Sure. So in this way, I have written this formula. Okay. Okay.
Ma'am, why are we taking joint of x and y?
1 minute. See, how do you find if you are given the joint distribution of two random variables, and you have to find the marginal of one? So what do you do? You take sum over the
Yes. We marginalize the other one out.
Okay.
Ma'am, for the given example where you took x as 0, 1, 2 and y is equal to 0, 1, 2,
Comma 3,
there, ma'am?
Yeah, 0,
Hello?
1, 2, 3, up to 3 4.
For both.
Yeah.
So the value for z would be in that case?
I just assume that z is x plus y, okay, and z was 4. X plus y was 4, okay.
Okay.
It was
So
just to show you, it was just a random example to show you that how I have written this, okay. So it is given to you that x plus y is z, okay. So if suppose x is taking as small x, then how you can find y? It will be z minus x only, right?
Correct.
Okay, so you can write it like this, so that x is taking value x, okay, x is taking value x, and y taking value z minus x, right?
Okay, fine, ma'am. I got it.
Okay, yeah. So this is the case. So if you need to find the distribution for z, you can use this formula, okay? And suppose if x and y are independent, okay, it is just another case. If x and y are independent of each other, then how we can write the joint? Suppose x comma z minus x, okay. So how you can write? The product of the marginal, right? Is it correct or not?
Ma'am, are you writing something?
And the screen is there.
Screen sharing.
Screen is not visible.
Scroll a bit.
Oh.
Just scroll a bit.
Freeze.
Just scroll
No,
a bit.
ma'am.
Now it's visible.
Yeah.
Go ahead. Now it's visible.
Okay, so I'm saying that x and y are independent. Okay, right? Then may I write it like this? The joint equal to the product of the marginal.
Yes, yes.
Yes, ma'am.
Okay. Okay. So if in case x and y are independent, then you can write the joint as the product of marginal in this case. Okay. Then if x and y are independent, then what will be the probability z is equal to small z? So you can write it like x, and it is fx x into fy z minus x, right? Is it clear?
Yeah.
Okay. Now we will take the sum of two Poisson independent tandem variable. Okay.
Ma'am, the last probability which you have written pz equal to z. If x and y are independent, then we are summing over x and marginal probability of x and the marginal probability of y z minus x. So
Yes.
that can also be written for y. Summing over
Yeah,
y
that
also
can
be
also be
right?
written for y also. Yeah, sure.
Okay.
Yeah. Okay. Like you can use this formula also, y case. Okay.
Okay, ma'am.
Yeah. But remember that if x and y are independent, then only you can write it like this. If not, then you cannot write it like this. Now the next thing is sum of two independent Poisson random variable. Okay. So now let us take that x1 or X, suppose X is following the Poisson with parameter lambda 1, okay, and Y following Poisson with parameter lambda 2, okay. So we have to find the sum of two Poisson independent random variables. So Z is equal to X plus Y, okay, and here X and Y are independent, okay. So how we can write the marginal of Z? Okay, so since X and Y are independent here, we can use this formula directly, right?
Yeah.
Okay. So see, what is the range of X here? So the range of Poisson distribution starts from 0 and goes up to infinity, right? It will start from 0 and it should go up to infinity. But here what it is given, that X plus Y is equal to Z, okay? So the maximum value that X can take will be Z only, right?
Yes.
Okay, so I will not take the range up to infinity, it will be only up to Z. Okay. So what will be the fx at point X? E to the power minus lambda 1 into lambda 1 to the power X divided by X factorial, right? Okay. And what will be the Fy at point Z minus X? It will be e to the power minus lambda 2 to the power Z minus X, okay, divided by Z minus X factorial, right? Now I am taking e to the power minus lambda 1 into e to the power minus lambda 2 as common. Also, yeah, this two things I can take as common. I mean, out of the summation, I can write it like this, okay? So it will be lambda 1 to the power X, lambda 2 to the power Z minus X divided by X factorial into Z minus X factorial. Is it clear to all?
Ma'am, are we assuming that X and Y can't take negative values?
See, X and Y are taking, X and Y are following Poisson distribution. Okay. And what is the range for Poisson distribution?
Okay, it is from 0. It can't go negative, right?
Yeah, it can't go negative.
Okay.
Okay. So it will start from 0. And since X plus Y is Z, so the maximum value the X can take will be Z only. So, okay, we don't need to write it up to infinity. We will write it in Z only. Okay.
Okay. Yeah.
This way. Okay. So is it clear to this point? Okay. Now what I am doing, I am dividing by Z factorial and multiplying by Z factorial. Okay. So now I can rewrite it like 0 to Z. Okay, it will be Z factorial divided by X factorial into Z minus X factorial into lambda 1 to the power X and lambda 2 to the power Z minus X. Okay. Now, do you know this formula that X plus Y to the power N, it is equal to the summation that N C K X to the power K and Y to the power N minus K. Okay. And K goes from 0 to N. This is the binomial theorem, right?
Yeah. Yes.
Okay. So this term is similar to this, right?
Oh, right.
Okay. What is the difference here is So I am writing e to the power minus lambda 1 plus lambda 2, okay, divided by z factorial into what is x. Here it is x and here it will be lambda 1, right? Okay, and here it is y in this formula, okay, and what is in this case it is lambda 2. So lambda 1 plus lambda 2, okay, to the power, in this case the power is n, okay, and in this case the power is z, right?
Yes.
So I can write it like lambda 1 plus lambda 2 to the power z,
Yeah.
right? Okay, and now you can compare it with the PMF of Poisson distribution. Okay, now what distribution z will be following? It will be Poisson with parameter
Lambda 1 plus lambda 2.
No, it's z.
Yeah, not z. It will be lambda 1 plus lambda 2, right? Z is a random variable here, okay, and lambda 1 plus lambda 2 is the
Because of the
parameter.
lambda.
Okay, so now what we can conclude, that the sum of two Poisson random variable is also a Poisson random variable, okay, and what will be the parameter for that? It will be the sum of the parameters only, right? Like in the starting, we can see that x was following the lambda 1 Poisson with lambda 1 parameter, and y was following Poisson with lambda 2 parameter, okay, and z was x plus y. So z will follow Poisson lambda 1 plus lambda 2, right? So if you are given a question, you can directly use this formula. Okay, is it clear?
Yes, ma'am.
Okay. Okay. So suppose now we will find the CDF of maximum. Next topic is okay. So suppose you are given. So if x is a random variable, okay, then what will be the CDF of fx, CDF of x? So we write it like fx. So it is probability that x is less than or equal to small x, right? Now suppose that x and y are independent and z is equal to the maximum of x comma y. Okay, initially in the previous questions we were taking z is equal to x plus y, but here the z is equal to maximum of x comma y. Okay, now we will find the CDF of z. Okay, so how we can write it? We can write that fz at point z. So we can write it like this, that z is less than or equal to small z. Okay, from this I have written this thing. Okay, so what is it? Z is maximum of x comma y. Okay, is it clear? Okay, and if maximum of two things is less than or equal to something, then they both will be less than or equal to that particular thing, right? So here x is also less than or equal to z. Okay, and y will also be less than or equal to z. Is it clear or not?
Yes, ma'am.
One of them will be equal to the z, right? But we don't know which one.
Yes. suppose we are taking that 3, 4 we are taking, okay, maximum of 3, 4, and it is less than equal to 5. Okay, so maximum is what? 4 is less than equal to 5.
Okay.
Okay, so here we know that 4 is less than 5 and not equal to 5, but here we don't know, so we are taking that x is less than or equal to. Okay, so 4 is less than 5, then 3 automatically will be less than 5, right?
Yes.
Okay, yeah. And here it is given that x and y are independent of each other. So I can write it like probability that x is less than equal to z into probability that y is less than equal to z. Right?
Yes.
Okay. And what it is? It is the CDF of x at point z. Okay. And it is the CDF of y at point z. Right? Okay. So this is the result.
Ma'am, can you scroll up a bit?
Yeah.
Ma'am, since z is already defined as maximum of x or y, then in the example where you took 3 and 4, then z should be one of the two, right? Z has to be 3 or 4.
Yeah.
Okay.
So in that particular example, we know that it is 3 or 4, but here we don't know what value of x and what is the value of y. Okay, so it is the general case. Okay.
Ma'am, what did you say about this particular thing? Why this probability x is less than or equal to z and y less than or equal to z, it will be the product of the two
Yeah, see,
probabilities?
it is given that x and y, in this case, we are assuming that x and y are independent. Okay.
Yes, ma'am.
So if x and y are independent, then we can write it like this. Okay.
Okay.
Okay, how it came that probability of A intersection B is equal to probability of A into probability of B if A and B are
Okay.
independent, right?
Okay, got it.
Okay. Okay, so we can write it like this also. Okay, now let's see example.
Ma'am, this result is true only for this max function.
Yeah, this is for maximum function.
Okay, not for
And if
other
x and y are independent. Okay.
Yeah, ma'am.
Yeah, this is if function is this only. Okay.
Okay, ma'am.
Okay. Yeah. Now we take an example that x is following the symmetric distribution with parameter p. Okay. And y is following symmetric distribution with parameter p. Okay. And we have to find the distribution of minimum of x comma y. Okay. So here we will see about the minimum case.
Ma'am?
Yes.
The earlier one, we didn't mention anything like geometric distribution or anything. That was generic, is it?
Yeah, it's general case.
Okay.
Yeah.
Thank
you. You can use the CDF of whatever distribution it is following. Okay.
Yeah.
Yeah. Sure. Okay. So we can write that probability of minimum of x comma y is greater than or equal to k. Okay. So how we can write it like that x will be greater than or equal to k. Okay. Comma y is also greater than or equal to k. So it is just opposite to the maximum case. Okay. So if the minimum value is greater than some point, then all the values will be greater than that point, right? Is it clear? So similarly, you can take like minimum of 2, 3 is greater than 1. Okay, so minimum is 2. 2 is greater than 1, then 3 will already be greater than 1, right? Okay, so in this fashion, I have written this. Is it clear?
Ma'am, we have to find minimum. And one will be minimum.
Ma'am, what if k is the value of k is more than any of the value of x and y?
So see, what I have saying that minimum of x and y is greater than k. Okay. Suppose you have a set of numbers. Okay. And the minimum is greater than something. Okay.
Minimum
So
is
suppose you
greater
can.
than something.
Okay. So minimum of like 3, 4, 5, 7, 10. You have this set, and minimum. What will be the minimum?
3.
And you are saying that it is greater than or equal to 2. So what is so minimum is 3. So 3
Yes.
is greater than 2. Okay. So it is the minimum. If 3 is greater than 2, then already automatically that
all
others will
be
also be greater than 2, right? 4, 5, 7, 10. All these will be greater than 2.
I am telling that if what if it's not 2, it's 11.
Sorry.
The right hand side is
Hmm.
not 2, it is 11. In that case, what will be the minimum?
It can't happen.
Then yeah, it cannot happen. This inequality will not be true, right?
Okay,
It is
okay,
given
okay.
that minimum is greater than or
Minimum is greater than
equal to
or
something.
okay, 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 okay.
Okay.
I think the probability just be 0 in that case, right? That's it.
Yeah, probability will be 0. Because that case is not possible.
Then what is the answer? What will be answer? We have taken this like previous example, 3, 4, 5, 6, 10. Then what will be minimum?
Sorry, what will be the minimum?
Yes, ma'am. Because it is written greater than and equal to 2. Then how it should be minimum?
See the example. Okay. So minimum you have to take that you are given 3, 10, 15, 12, 7. Okay. You are given this set. Okay. Suppose you are given this set.
Yes.
Okay. And you are talking about the minimum value. So what is the minimum among all these values? It's 3. Okay.
Yes.
And according to the inequality, it is given that this minimum value is greater than or equal to some value. Suppose it is 1. Okay. It can be 3 also. In that case, this equal to equal to will be true. Okay. Suppose it is 3. Then rest of the values will automatically will be greater than this value or equal to.
Yes.
Right?
Ma'am, what will be if it will be 1 or 2? What will be answer?
So you are saying that minimum of 1 and 2 is greater than
No,
equal
ma'am.
to?
Here 3. Ma'am, 3.
What 3, sorry?
Yes, ma'am. 3. In place of 3, it will be here greater than or equal to 3. It will be 1 given then 1 or 2.
The
Sorry,
value,
I did not understand your
okay, the
question.
p value is for k, not for x, right? The above one example. If you talk about.
Yeah, here it is written minimum is equals to 3, greater than and equal to 3. That's what I was saying. If it will be given 1 or 2.
Okay.
Minimum is equals to 3, greater than or equal to 1.
Uh,
Then what will be answer?
okay, let me write what you
Yeah.
are saying. Okay. Okay. Wait. Okay. Yeah. Yeah. Tell me what you are saying.
The minimum is equals to 3,
Minimum equals to 3. Yeah.
greater than or equal to 1. Then what will be answer? Here it is 3, 10, 15, 12 and 7 all are greater. Then how it will?
Yeah. So it is, I am just saying that 3 is greater than 1. Okay. So now automatically you can say that 10, 15, 12, 7 will be greater than 1 or not.
Yes.
Yes.
Okay.
Okay.
Is it clear to you or?
Yes, ma'am.
Okay. Okay. So now here,
Ma'am, you're trying to find out value of z, which is minimum of xy at point k. This is how you are taking k.
how I am taking k.
Yeah.
So k is any value that will be given in your question. It's a general value.
So you're trying to figure out distribution at k, right?
Yeah. See, what I am trying to find in this question, I am trying to find the distribution of minimum of x and y. Okay. So this is just one step. We have some more steps for this also. Okay. This is not the distribution. Just wait for a few minutes, then you will see. Okay. This is the probability that this function is greater than or equal to k.
Sure.
Okay. Some more steps are there. Then we will find the exact distribution. Okay.
Yes, ma'am.
Okay. Okay, and x and y are independent also in this question. I did not write it, sorry. X comma y are independent. Okay.
So it's an
Then it's
IID.
in, yeah, it will be IID also. Okay. So in the same manner as we write in the above question, so we can write it like this. Okay. Is it clear to all? Similarly to this case, as I have written there.
So ma'am, the function max xy or min xy, we are treating it in the same fashion, right? Max xy greater than or equal to k is also equals to probability of x greater than or equal to k, comma y greater than or equal to k, and min
See, in
also.
minimum
When we can
case, in minimum case, it is greater than or equal to k, and in maximum case, it was less than or equal to some value.
okay.
Okay. Okay.
The
So
minimum also we can the way we proved for the maximum, we can prove for minimum also, right?
we can prove for that also. Suppose if something is given that minimum of x and y is less than or equal to some k, then we can write it like 1 minus probability, like its complement can be written. Okay.
Okay.
Okay. In that way, we can find if the inequalities are opposite. Okay.
Okay, ma'am.
Okay. Yeah. So initially we have find this value. So here x and y are following the distribution symmetric p. So what will be this value? It will be 1 minus p to the power k minus 1, right? So we have solved this earlier in the memoryless property. Okay. So by this formula, I have written that value. Is it clear to you all?
Yes, ma'am.
Okay. Okay. So similarly, we can write it for y also, right? Both are following same distribution, symmetric with same parameter p. Okay. So how I can write it like 1 minus p to the power 2 k minus 1. Okay. Now I will find probability that minimum of x comma y is greater than or equal to k plus 1. Okay. Now in the same manner, I can write that x is greater than or equal to k plus 1, comma, y is greater than or equal to k plus 1, right? Is it clear? Okay. And this value will be 1 minus p to the power k okay into 1 minus p to the power k. So it will be 1 minus p to the power 2k, right? Is it clear? Hello.
Yeah, ma'am.
Ma'am, can you explain?
Yes. Why are
Yes,
you doing
ma'am.
k plus 1? Anything to prove it or?
So this step is clear to you all or not?
Ma'am, could you scroll up?
How I have written?
Ma'am, explain it.
Okay. Okay. So see, in geometric distribution, what I have find earlier, so it was probability that x is greater than n, then it was 1 minus p to the power n, right? And here I am writing that probability that x is greater than or equal to k. Okay, so suppose greater than or equal to n. Okay, so here k is equal to is also included, so it will be 1 minus to the power n minus 1, right?
So,
Since
ma'am,
what it is saying,
ma'am, is this a
see,
property?
I have solved it in the memoryless property, this formula.
Yes, ma'am, that was given.
And in the similar way, I have written for x is greater than or equal to n.
Ma'am, why that I'm really not getting how come you can conclude from first.
So I have, okay, so are you clear with this point? First one?
Yes,
I have
ma'am.
already explained it
Yes,
in the
ma'am.
session, okay? Okay, so here what does it mean? Try to understand what this statement is saying. It is saying that x is greater than n, okay? Which means for the n trials, okay, you did not receive the success, okay? So there are n failures. So
Correct.
it is 1 minus p to the power n,
Correct.
okay? And here what it is, that x is greater than or equal to n, okay? So it is saying that maybe at x equal to n and its trial, maybe you got first success. So there will be n minus 1 failures. Okay.
And then
So
there will
that's
be a
why,
term of P, ma'am, with it also.
see, I have solved it, how it came. Okay. It's not PMF I have written. I have solved this earlier also. How does it come? See, okay. It is not equal to n. Okay. How it comes is in this manner.
Ma'am, for P greater than X, Px greater than N, I understood that. But when you say P of X greater than equal to N,
So see
you are
how you can
saying
find
that.
it. You just, okay.
Uh-huh.
So you are not understanding for x is greater than or equal to n. Okay.
Yes,
So in
ma'am.
the similar manner, you can find for this equation also. What you will do, the change will be that x will start from n instead of n plus 1. Okay. Here it was greater than n and not equal greater than or equal to. Okay. So we started the range from n plus 1. And here x is also taking the value n. So the range will start from n. Okay. So you just need to take or you need to solve this equation. Okay.
Okay,
And you
fine.
start the range from n, then you will get the same answer. Okay.
Sure, ma'am. I'll do it, ma'am.
Yeah. Okay. And in the similar way, I have written for k plus 1 also, right? Now is it clear?
Yes, ma'am.
Okay. Okay. So we have found for these two cases when minimum of x and y is greater than or equal to k and minimum of x and y is greater than or equal to k plus 1. Now we have to find the distribution. Okay. So it should be, so basically what we have to find that probability that minimum of x comma y is equal to k. Okay, so this is basically gives you the probability. And how I can write it like? We can write it as probability that minimum of x comma y is greater than equal to k minus probability that minimum of x comma y is greater than or equal to k plus 1, right?
No, ma'am, this is not obvious to me.
This is not obvious. How?
To me, I mean.
Okay. See,
Ma'am, basically we
how,
are subtracting the two CDFs.
yeah, I am
Okay, ma'am.
subtracting this from this part to
Yes,
this
ma'am.
part,
Got
then
it.
you will get this. Suppose it is k and it is k plus 1. So it is greater than equal to k. Okay, and it is greater than or equal to k plus 1. So from this, you are subtracting this part. So only this part will be left, right? At point k, right?
Yeah. You
Okay.
mean the range between k and k plus 1?
No, since it is a discrete case, it is not k, it is the distinct values k and k plus 1. It is a discrete case, so
Oh,
no
okay, okay.
values between this, okay?
Okay,
It is
okay.
not continuous, so no values will be between in the k and k plus 1, okay? Now is it clear?
Yes.
And how
Okay.
you're defining that you need to subtract from k to k plus 1 and not other way around?
You can take others also. It is just a general case, okay?
No, other
You
way
can,
around. Why you have not written minimum of x comma y k plus 1 minus 2?
no, it will be opposite, right? It will not give you that, sorry, what you are saying that k and k plus 1.
Yeah.
So what you are saying that what should be according to you?
I'm saying you have taken k minus k plus 1 probability, right?
Hmm.
On what
Hmm.
basis you have taken that? How do you know that probability of k is greater than k plus 1?
Okay, so see,
It's not probability, it's CDF. Sum of
suppose
probability.
these two, okay. So what it is saying that in this case you are taking greater than or equal to 2, okay, which means it will be 2, 3, 4, 5, and so on, or whatever the value the variable is taking. Here I am taking up to 5 only, okay. And in the next
Sure,
part
it's
you are
clear.
saying
It's
that,
clear. It's clear, ma'am.
okay,
It's clear. Thanks.
so you will be subtracting this part, so only this part will be remain, okay. Now it's clear.
Yeah, it's clear.
Okay. Okay. And we have calculated these values. So we just need to put these values into the formula. So it is minus 1 to the square whole power k minus 1. Okay, from this part, this thing. Okay, and the next is 1 minus p to the power 2k, or simply you can write it like this also. 1 minus p square whole power k, right? Now let us assume that I am representing 1 minus p square as L. Okay, so how you can write it like? It will be L to the power k minus 1 minus L to the power k, right? Just for simplification, I have written it like this. Okay, so it will be, you are taking L to the power k minus 1 as common, so it will be 1 minus L, right? Okay, now can you compare it with the PMF of geometric distribution?
Oh, right. It's in similar form.
Right? So
Ma'am,
what
how
will be
did
the
we get
parameter?
1 minus p square?
Sorry?
How did we get 1 minus p square to the power k minus 1? 1 minus p square, how did we get?
See, I have written the value. The first term is minimum of x and y greater than or equal to t. So we have calculated this value and it came like 1 minus p to the
Okay.
power 2 power k minus 1. Like,
Okay, ma'am, got
like,
it.
okay, in the similar way, I have written for this also. Okay. And
Yeah.
for simplification, I have written 1 minus p square is equal to L. Okay.
Yes, ma'am.
Now, is it similar to the PMF of geometric distribution? So what will be the parameter?
P square?
No.
L.
So see, if x is following geometric
Okay.
with parameter p, okay, then what will be the PMF? At point x, it is 1 minus p to the power x minus 1 into p. Okay. So here, what is P? You can compare what will be the value of P, or you can take, if you're getting confused, then you can take another also. Let's not take it as P, otherwise you will get confused. Suppose it is taking M, then it will be 1 minus M into M, right? Now compare M with this, okay?
Yeah, it is L.
L over here.
So what is
L.
M here?
L.
It's not L, it's 1 minus L, okay?
1 minus L.
Oh, yes, yes.
Okay, 1 minus 1.
Okay, 1 minus P square is.
So here 1 minus L is the probability of success, okay? So the minimum of X and Y will follow the geometric distribution with 1 minus L. And what is L here? L is nothing but the 1 minus P whole square, okay? Right?
Oh, ma'am, in that case, we end up having P square, no? Oh, sorry. It's whole square. My mistake, ma'am. My mistake.
Yeah, it's a whole square, not.
Yeah, ma'am.
Okay. So yeah, this was the topics in the week 2. Now, if you have any doubt, you can ask.
Ma'am, I have one access issue. Like if I try to access the recording or the documents, I'm not able to access for all the sessions.
On YouTube or portal?
On the calendar, from the calendar, if I click on the link for recordings for the previous sessions or for the documents, I mean whatever you are creating the document, both are not accessible to me.
Yes, ma'am. Same for me.
I mean, I put this on the discourse, but I still know it's not resolved.
Okay, so on calendar, the YouTube link it's not accessible, you are saying?
Yes, and whatever the recording is there on the calendar, I am not able to access, and also the document which you are writing.
The documents, so see, this PDF we will upload, like for week 1, I think it's uploaded on the portal.
But is it accessible through calendar also? It should be accessible, right? But I am not able to access through calendar.
Okay, is it accessible from the portal?
Portal I have not checked, but from calendar, the recording and document both are not accessible to me.
Okay, we will check that.
Yeah,
if there is
please.
an issue. Okay.
Yeah.
Yeah, anything else? Or we can end the session.
Ma'am, for this kind of questions, I mean, for this kind of okay, for minimum, what kind of questions can we expect? It will be only based on geometric, or can it be something else as well?
No, it can be from any distribution. Okay, what you just need to see. So here it is following the geometric distribution. So that's why I have written the formula or the CDF or anything according to the geometric distribution. Okay, and whatever the distribution will be given to you, you will be writing according to that only. Okay.
Okay, so we will have to derive this for the other kind of distributions as well, is it?
Yeah, you can derive.
Okay.
Yeah. Anything else?
Oh, ma'am, can you just scroll to the last page, ma'am? Just wanted to note down the result.
This one?
Yes, ma'am.
Ma'am,
Yes.
ma'am, I have joined late. Then can you tell me what was that? What you have taught earlier?
The entire session you are talking about?
No, ma'am, I have joined in the mid of the session. So in the start, what you have
Okay, so simply in the week 2, what we study about the independence of the random variable. Okay, so first you will study if two random variables are independent. Okay, okay, have you written this? May
Yes.
I scroll down? Someone was writing it, I think. So the first thing is if x and y, two variables x and y are independent, okay, then there is a condition that their joint distribution, joint PMF at like T1 or T2, okay, it should be equal to their marginal distribution, to the product of their marginal distribution, okay. So this is a condition for independence of two random variables. And suppose if there are multiple random variables, suppose x1, x2 up to xn, then the condition is similar to this. That is the joint of these random variables, okay, it should be equal to the product of their marginals, okay. So see, you don't need to mug up the formulas. You just need to understand how I have written this thing, okay. So the only thing to remember is that the joint will be equal to the product of marginal, okay. If you have two random variables, three random variables, or n random variables, okay, you just need to write this thing, okay. And what we do, we just check this condition for every case, for each value of x and y, or the variables whatever the given in the question, okay.
Yes.
And this condition should be true for all the values, okay, like for all t1 belongs to tx, or for all t2 belongs to ty, okay. So in the similar here also, like ti belongs to txi, okay. And if for any case it's not the condition is not satisfied, then x and y or the variables will not be independent, okay. And next we study about the functions of random variables, okay. So there were some questions which I solved, okay. You can see and you will understand it, okay.
Yes, ma'am. That I have saw, but in the start of the session, I have not joined them.
Yeah, so in the starting, this thing was there, independence was there, okay. Independence for two random variables for x and y first, okay. Then I solved two questions, okay. And then for multiple random variables, and then it was there was a IID random variable in which the random variables should be independent of each other, and they should be following the same distribution, okay, with same parameters.
Ma'am, this session is recorded.
Yeah, it will be recorded, and you will get the link in the calendar, YouTube link, okay.
Okay.
You can see the session there.
Yeah. Okay. Thank you.
Okay, sure. Yeah, anything else?
Ma'am, I have a doubt in the graded assignment of week 1.
Okay. So see, for graded assignment and for practice assignment, you will be given the solutions. I think for graded assignment, the PDF is not uploaded yet, but we will be uploading it by tomorrow, I think.
Okay, ma'am.
Okay, then you can check that. Okay.
Yes, ma'am.
Okay, fine. Now, may I end the session?
And this PDF will be also available?
Yeah, this will be available.
Okay.
Thank you.
Okay, yeah, thanks. Thanks to all for joining.
Thank you, ma'am.